In this video today, I'm gonna solve problem 155, min stack, and this one is also a medium problem as well. So, it's also a design problem too. So basically, what they ask you is that you have to make a class stack that can support those common methods, and also one special one, which is retrieving the element in the stack in just constant terms. So for example, you have an empty stack here, and then you can perform like push new number to it. You know, push 1, push 3, push 5, push 2, push 6 into that. And from it, let me change the order of this one a little bit. Let's move 2 here and 1 here. So, and this is the push method. And how about the pop method? So when the pop method, you gotta pop from the last one. So because stack is the first in, last out, which is also the philo, the signature everyone know. I hope that. So let's get back to here. So when we perform a pop on the stack, we're gonna delete 6, right? So now if they ask you to get the mean value of this whole stack, it's gonna be run, right? Very simple, very easy. And now if you want to perform a pop, perform a pop, you can just continue, and then you can actually call a top method to get the value 5. So top would return you a 5, right? And now here's the important thing. So you guys need to also have like a retrieving minimum element in constant time. So in this case, if you guys want to retrieve the minimum element, it would return a number 2 here, because 2 is the smallest element in the stack. So here's the thing. So if you want to get into 2, in normal case, what you have to do is just you have to pop everything until you get to the last one. But in this case, it just asks you to do a constant time. So if you do like that you pop everything and you start it in a temporary stack and then you pop it again, that's one it's not gonna work, because that one would close to O(n) or O2n specifically time complexity, and it's not constant time, it's a linear time complexity. So what I'm going to give you guys a hint is that whenever you guys use a constant time, you guys gonna know that what we have to do is find something like the memory. We have to use the memory, or we can make a for loop in just a constant number. It's not gonna be changed over time, but in this case, you guys just have to worry about the memory. So you guys gonna use the memory like the hash map, hash a vector or something to actually approach this problem. So that's my intuition. So intuition. So whenever I see a problem that asks me to implement in a constant time, I would immediately think of the memory, using the memory, and that's how I can approach this problem. So let's get back to how I can come up with the idea for this one. So basically, we're gonna have like let's see. So 2, 3, 5, 2, 3, 5, 1, and 6. So here's our stack. So the pop, the top, and the push is pretty similar. So I'm not going to talk much about that. I'm going to talk about the get min, which is also the name of this problem. So I'm thinking of how to get a minimum value. So in this case, we know that if 6 is still here, if 1 is still here, we're gonna have the minimum value of 1. But if we delete it out of the stack, we pop it out, we're gonna have the minimum would equal to 2. So what I'm saying here is that it also depends on the state of the stack. So for example, you guys gonna see that if 6 here, the minimum value of it is gonna be 1, right? How about this one? So if 1 here is also the minimum value, it's also 1 here. How about 5? So if we pop 1 and 6 out of this stack, we're gonna receive like 2 as our minimum value. And also for this 3, we also 2, and this one is 2 again. So that is a the thing that you have to know is that in order to get the minimum value, we must have some kind of like variable to store the state of each, to store the minimum value of each state. As by state, I mean that which state, which element at the top. That's very important. So you're gonna see that the state is changing. It's not changing over time. It's only change whenever you met a new element that is smaller than the minimum value in the previous state. So that's how I come up with the idea. I draw something up, and then when I look at this one, I kind of feel like, oh, we with a normal stack, we just store like a single value, right? But I kind of feel like, hey, wait, they have a pretty cool data structure that is called a pair. Or in Python, it's going to be a tuple. So a pair integer of integer. So here's how thing works. So you're going to store the actual value in this one, the actual value of a stack. But in the second one, you're going to store the minimum value. Right? Minimum value. So that's how I come up with this problem. So when we top, so now when we perform some method, you're gonna see like, if we perform a pop, we just completely delete the whole thing here. If we get a top, we just need to get the top one on the right, on the left. And if we want to push, we have to push both of them into the stack. So instead of the stack integer, we're gonna delete it, and then we're not going to use that. We're going to use the stack of two integer. So let's say the actual value and also the mean value. So this is the stack that we are going to use for this problem. This is not a very really tricky question, but it asks you to have a very solid understanding of the data structure, so that you can use of it. And also just a hint, also the keyword for that is whenever we talk about constant thing, we gotta know that we are talking about how we can use the memory better. And that's how I can solve this problem, this medium problem. So now let's go to how we can code this one. It's very simple, guys, trust me. Alright, so here's the code for this one. I'm still going to code this one in C++. I can code this one in C#, but I think coding in C++ is a little bit, faster for me. The syntax is, I kind of find it familiar to code in C++ than actually code in C#. So now let's get back to it. Right, so as I have mentioned, we're gonna use a stack that store a pair of integer here, right? So the first one is gonna be the actual value. Let me put the value here. And the second one here is going to store the minimum value of that state. So as you can see the push here, when we push the element, what we have to do is actually also need to assign a minimum value to it at the end, right? So how we can do that? So we have to make a temporary current min equal to value. And what we have to do next is we check if the stack is empty or not. So if it is not empty, and also if the second element of the current top, which is the minimum value. So if, for example, we are like this, like 2, 1, oopsie. 1, 1, 2, 1. And then we have 3. So when we insert the 3 into it, we have to check if this the current min of the element of this one, we firstly we assign it to 3. So if one is smaller than 3, so we have to reassign the 3 here equal to 1 again, and then we push to the stack, so we will be 3 and 1 here. So what we have to do is just simply firstly assign the value of it to the second one, and then compare it with the one on the right. So that's how we can push the element. It's very straightforward. And for the pop, we just pop the element. And for the top, we just return the one on the left, which is the first element. And the top, we just return the one on the right, which is the second element. So we can easily calculate the time complexity of this one. It's all 1 for everything. And yep, this is how you can solve problem min stack. Let me write something here. And for the space complexity, it's just also O1 as well, because you're not using any additional vector to store the minimum value. I'm about to mention the how you can actually store the minimum value using vector, but it can be a little bit more complicated. So, congratulations everyone, you have solved the problem, a medium problem. Thanks for watching this video. See you guys again in my other video. See ya.